All right, so a quick rundown of differences from Java to C++ for you to get started for your second year. So this is Visual Studio, which is our editing environment. Generally speaking, you're going to be in debug mode on 32-bit, which is x86. You can change it to 64, but realistically, you probably shouldn't. 32 runs everywhere, 64 only on 64 machines. This is your compile button, or you can hit F5. Instead of imports, we use pound include. A basic one here is IOStream. The note here, this is master library. Master library is denoted by the angle brackets. So this is part of the language. So if you wanted to use strings, strings are not natively part of C++. You need to include them. And this include here is demonstrating a local or a programmer-defined class that I made called test class. We use something called namespaces. A lot of people will post online and say you really shouldn't do this. While I pretty much agree with that, I think for students this is fine. We have other battles to fight over memory usage, which is actually something we can control much better in C++ over Java. We use the word constant instead of final. So this is an integer, just like in Java. This cannot be changed, and it has to be set immediately. I'm not quite certain if the Java class pushes standards and conventions so much that I've written, but we use Camel Casing for variables, and in the terms of globals, or sorry, shouldn't really use globals, but constants need to be all uppercase so that we can identify them. Camel Casing doesn't work in that instance, so this is where you can use the underscore in this naming convention. Camel Casing, void, you should know. We have to prototype our functions. Also note, there is no class here. Java is 100% object-based, which means you always have to make classes. Not the case for C and C++. We always start at main, just like you should be used to. These are your basic primitives: int, bool, char, double, so integers, bool instead of boolean, char for single characters, doubles for real numbers, floating point values, and string again is class, so I imported it up above. To print, we use cout, and if I didn't have the using namespace std, we would have to put std : in front of cout. In fact, we'd also have to put it in front of str. We'd have to put it in front of cin. So this is cout, this is cin. So output is never formatted. You have to take care of it yourself. Cout, stream insertion, whatever you want to push out there. You can push variables, string literals, strings, whatever. This cin grabs information from the keyboard and puts it to the variable. You will throw errors if what you get is not the expected data type. There are ways around this, and we might take a look at that later on in this year. But essentially, if you write a program and the expectation is right here, like, hey, give me a number, the user should give you a number, and also they should follow any instructions that you've given them. Logic control statements should be roughly the same. You do not need to use scope if you're only controlling a single line. If you're controlling multiple lines, you must use scope. I would prefer this style if you are not using, if you don't require scope. You should not make scope for a single line, and scope should also open on a line by itself. I know in Eclipse and whatnot, they like to put it up here. I dislike that. I want it on a line by itself. So you have if, else, obviously you can nest. There's also switch. Switch is essentially a very long if-else chain of literal matches. It only works on whole numbers. So that would be int or char. And so with a switch, you switch on a variable, and you write case logic. So when I is 0, do this. When I is 1, do this, so on and so forth. Case logic is starting points, so it'll come in here and start working down. Break takes it out of the control structure. That's what keyword break does. You should only use keyword break with switch statements. A default is like a trailing else. It is a catch-all sort of situation. So if I took this break out and I was 1, it would print 1, and wow, I don't know that number. So we use breaks to, if cases are meant to be standalone, you're not required to use a break, and obviously we don't put one in the default because the default should be the last thing before you lose scope. Loops are pretty much the same. You have your while loop, you have your for loop, and then we have a do while loop. So do while is 1 to many repetitions, a while loop is 0 to many repetitions, and a for loop is for a set number of repetitions, when you know exactly how many, when you are unsure if you want any at all, and when you will do a set of actions at least once, you use the do while. This is a function call, which is a lot like a method call. You've seen that. Exit success is a macro. You can use this or simply have return 0 at the end of main, and it all does the same thing, passes control back when your program's done. So functions, like methods. So we write a prototype above main, and this is your grouping. Up here you would have your header information. Then your includes, namespaces, any globals that you're going to use. Generally speaking, globals are bad. Then your prototype of functions. Then you would get to main. Standards and conventions will tell you 2 lines before. And any function, so always 2 blank lines. Functions are just like methods, no big deal here. And if you want to add classes, it would be project, add class. You'll get a little wizard as you start typing in the class name. It will start making the appropriate files for you, and you'll get 1 under your header files, which is the .h, and then 1 under source files, which is the .cpp. H for head, and CPP for C++. This is where your class definition goes that you're used to seeing in Java. So it's class, whatever class name you want to give, constructor, and here's another difference, is a destructor or deconstructor. Java does that management for you automatically. We have to do it ourselves because we actually have the ability to directly manipulate memory and acquire it, which is something that we'll be going over this year. So under the public section is where you put all your forward facings. We group public together and we group private together. Arrays are a little bit different in C++. We define how big they are. Because this is a .h file, we don't put any implementation code in it, so this is just an array of 4 integers of garbage data. We always have to declare size. This has to be a literal value, and the general breakup of this is anything that you want the outside world to touch goes under public, internal pieces go into private, so this is where your data members go. Any sort of assistive methods, that sort of stuff. In our implementation file, we have to include the .h, and this is your scope resolution operator, the double colon, and it says where what. So I want to define test class, and you will find the definition for test class in the file or in the class, test class, which I've included. So right here, all I'm doing is setting the array to values 0 through 3. Essentially, the constructor, as you know, is your set this thing to a good state before any work happens. And your destructor is where your cleanup instructions go. Pardon me. And that's really something we're going to be exploring a little bit more this year. So don't worry about that so much. And again, to run it, you just click the little play button, and so it should say hello world, give me a number, and we can see those while, for, and do while loops all were structured to do the same thing here, and the function call to say see you later. And so that is your super quick conversion piece from Java to C++.